Please turn to the bottom of page 1. We're going to continue our discussion of blood vessels. Start off with your arterioles. They're pretty important in terms of controlling blood flow to the capillaries. They can vasoconstrict. If they vasoconstrict, blood flow gets to the capillaries, and if they vasodilate, more blood flow. So because they can control blood flow or impede it, sometimes we call them resistance vessels. And again, they have all three layers: your tunica intima, tunica media, tunica adventitia. Not too much on the arterioles. Let's talk about the capillaries. Now if you look at it, other than having a base membrane, it's just your endothelium. So these guys are just one cell layer thick. And by being one cell layer thick, they're perfect for diffusion, because whatever needs to be diffused, may be a gas or nutrient, just has to go through one layer of cells that are flat. They're just big enough to allow the passage of red blood cells. If you take a look at this, in this image, there's really not much room for the red blood cell to pass by. And actually, in some of the capillaries in the brain, the capillaries are so small that the blood vessel actually kind of becomes the shape of a bullet in order to work its way through it. It's just the blood vessel is actually tinier than the red blood cell itself. But luckily, red blood cells can get deformed. They can change their shape. So anyway, looking at this, I kind of point out this thing called a tight junction. You want to remember that from 210, its function? That's right, it's a connection between epithelial cells that's rather impermeable. So stuff really can't get in between them, but stuff can go into and out of the cell itself. Okay, so just enough room for the red blood cell to get through. And sometimes not even enough room, but the blood cell can't change shape. Look at here, you can see it where, imagine if this red blood cell, this person had, sickle cell. All the red blood cells are kind of getting connected in the form of letter C, and sometimes they lose their ability to change shape. They get clogged up. There's not really that much room for error here. Again, it's just one cell layer. So we can have nice diffusion. If we look at this, we're going to get some good anatomy, some good physiology with this set of pictures here. And first thing is, let's take a look at this. We can see the blood flow is overall going in this direction. You have your arteriole, and you have your capillary bed. You can see where the arrows are. And there's also other places for the blood to flow through. You have what we call a meta-arteriole. Eventually becomes this thing called a thoroughfare channel. Now, let's think about this. First thing is there always blood flow through capillaries? The answer is no. Depends upon if the tissue is being active. If the tissue is being active, you'll have blood flow, and sometimes we'll just call blood flow perfusion. Blood flow can be referred to as the word perfusion. So let's think about this. We'll call this case 1. Let's have a situation. You're about to have a picnic in a nice secluded area, just yourself. You found a nice pretty area, got some food that you like, and you're eating. And as you're eating, would this describe blood flow through your, let's say, stomach and your intestines? Probably yes. Fair enough. And this guy comes over, and he says, hey, and you say, hey, what's up? And he says, do you like to play games? And you're like, well, yeah, sure. Well, I got a game I like you to play. It's called Hunt. He takes out a big machete. He says, I'll give you 10 seconds to run. So now let's think about this. Blood flow through the stomach, blood flow through the intestines under those conditions. Is it case 1 or is it case 2? And this is blood flow through the intestines. Be case 2. So you don't need blood flow through the intestines under these conditions. Let's go back to the original picture. Now, blood flow through your legs as you're running. Is it case 1 or is it case 2? Well, probably be what? Case 1. Because don't you want good perfusion, take care of lactic acid, provide oxygenation nutrients? So we can't just say in an emergency blood vessels closed. We have to think about where those blood vessels are. So if it's in non-critical systems such as GI or renal, because they're really not going to be that important, you don't want to necessarily make urine when you're running for your life, and you don't need to worry about metabolizing foods in terms of breaking it down. You have stored fat, you have stored sugars you could tap into. So what's going to determine whether the blood goes through the capillaries or not? Well, there are these guys called pre-capillary sphincters. Sphincters like a valve, before. These guys are before the caps. So if these guys constrict, you're going to end up like this. And how does the blood get from the arterial to the venous return? Through the meta-arterial and the thoroughfare channel. Well, who controls those guys? Turns out there are these guys called vasomotor nerve fibers, and that sounds mighty scary, but you actually know them because you have something very similar in terms of skeletal muscle. Remember motor neurons? Motor neurons are neurons that innervated your muscles and cause them to contract through the release of acetylcholine. Well, vasomotor nerve fibers are coming from the sympathetic nervous system. We said a little bit earlier, what controls the smooth muscle? Sympathetic. So you have the sympathetic nervous system in your brain, let's say the medulla for argument's sake. The medulla controls this. How does the medulla connect up to your smooth muscles? Through the who? Vasomotor nerve fibers. Vaso stands for blood vessel. Motor, it's going to go to a muscle. That's a nerve fiber. Bunch of axons. Except this stuff is going to involuntary muscle, your smooth muscle. So when the sympathetic nervous system fires, these vasomotor nerve fibers will fire, causing the precapillary sphincters to close. Now you think, well, they'll close body wide. Well, you'll see when we do blood vessel physiology, there's a couple of tricks of keeping them open in your legs, in your heart, so you could get proper perfusion. Let's do another example with temperature control. Let's say it's too hot. Is it going to be case 1, blood flow to the skin, case 1, or case 2? If it's too hot, it will be what? Case 1. This way you could lose heat. And if it's too cold, it will be case 2. Here's your pallor right here. In the previous case, you have your erythema by having blood flow, red, warmth, because you're releasing the heat. Okay? So we kind of connect some of this stuff up with stuff we saw in 210. And we're going to keep seeing this again and again, so try to learn this as best as you can. So let's say that takes care of capillaries. And then capillaries lead to venules, which are tiny veins. And the venules will converge and give us veins. Veins are larger lumen and thinner walled than arteries. Why? Why are they thin? I think we already said that, because they're under lower pressure. And because they're under lower pressure, we could have problems with backflow. We don't want that. So let's take a look at a solution. Look at these valves. First thing is, when you look at their anatomy, AV or semilunar valves. Well, what's the one trick telling one from the other when they're not in operation? Well, there's no stringy stuff. They're semilunar valves. Watch this. See how there's no backflow? You can have a lot of valves in your lower extremities because this is where you're fighting with gravity. In your head, you really don't need valves. The blood's just going to go straight down due to gravity. So these valves are the solution. But if they become incompetent, the blood's going to pool. Blood's going to pool, and you'll have problems. Actually, let's see how smart you guys are. Is the blood flowing case 1 this way or case 2 this way? Let's say it's what? Case 1, because think about it. Going this way, this is going to go that way, this is going to go that way, and when the blood finishes going through, a little spring mechanism, they'll snap shut. So anyway, when they become incompetent, you're going to have some blood flow problems. Blood will accumulate in lower extremities and the veins themselves, cause them to dilate, and they show themselves as varicose veins. And it's usually not that much of a problem. However, in some cases, yes, it can be very, very unsightly, and I don't think laser surgery will fix this. Need a vascular surgeon and probably lots of support hose to help that venous return there. What else can we say? If you have phlebitis, it's inflammation of the veins. So if you have, got some venipuncture that wasn't done properly, possibly get phlebitis. Remember, phlebotomy, dealing with taking blood from the veins. A phlebotomist is who does